Okay, that's okay. So, hi everybody. I'm Mehran, and I'm going to talk about programming with OpenAI on .NET Stack, especially with Semantic Kernel. So basically, today we're going to talk about how these LLM-based models and AIs are working a little bit. I assume that most of you have some background about the LLM AI models and how they work, but we will explore a little bit on them. And then we will start talking about semantic kernel on it and how we can write effective softwares and LLM-based softwares which are uh, reliable and tested. So essentially, we will talk about test-driven development on OpenAI products. So first of all, I want to talk a little about what a language understanding and prediction is, or essentially what is an LLM-based application. So an LLM, the large language models, uh, opened a very new era in the programming because uh, uh, they brought something totally new to the on the table. So what's that? It is that it is something that can understand the language, the people's language. So far, out of the efforts to build something that can understand people's language was not quite successful so far until we have LLMs now. So with LLMs, something very interesting about them is that uh, they have a infrastructure that they can understand the language. You don't need to train them to understand English language or Persian language or any other language. So that's out of the box feature that they have. And also, not only they understand the language, also there's another cool feature packaged with them, and that's uh, a part of generative AI. So in generative AIs, with generative AIs, they can generate tokens. So they can predict what would be the next token after this token. Uh, let's talk about this a little bit because we will need this in our presentation. So essentially, a LLM is a huge model that when you give it a text, a part of a text, it will predict that what would be the next word, what would be the most appropriate uh, token or word or sentence that could follow this text. So, for example, I've uh, I've picked this example from the learning platform, the deep learning platform AI. You can find the full video there, but I've picked this picture from here. So, for example, consider you have you have a text. My favorite food is. What would be the best word that can be used in the following of this sentence? For example, we can check. Let's check Copilot, the Microsoft Copilot one here, the copilot.microsoft.com, to see what we suggest for my favorite food is. So if I type here my favorite food is, it statistically it checked all the language models. When it was trained, it learned somehow that pizza is a proper word to be followed by this specific sentence. So essentially it's saying that pizza is a valid token. It generated pizza as a valid token that can be followed by this sentence. But something that we have in LLMs is called temperature, is that whenever the temperature is 0, so how many times you test this, you will get this answer pizza. But when you get the temperature higher, that the higher temperatures, it will try some other different things. For example, when you set the temperature to 30%, at 30%, it is 30% possible that the generative AI picks the next proper token for this specific sentence. So it is highly possible that it suggests sushi, for example, or if you set the higher temperature, for example, 70%, it's 70% possible that it followed the sentence with another word, for example, tacos or sushis. So this is how the generative AI works. And in our meeting today, we're going to see how we can build products and softwares over this platform. For such API is available in Azure, which I am using it for. So you can see we're using Azure OpenAI Studio, and I've deployed some models in it I will use them in this presentation. For example, I've deployed some GPT 3.5 turbo and a GPT-4o model. So these models are deployed on Azure, and there are some keys to this that I will use them in my presentation here. Great. So let's get back to the comments to see if it is any question here. Hi, Majid. Nice to see you. Hi, Yasser. Very glad to meet you here. Hi, Hutan. Very nice to see you here. Okay, so if you had any question, just drop the question here. I will see it and I will answer it at the proper moment. Great. So in this presentation, as we saw so far, I've talked about understanding the language, how the predicting the next sequence is working. What we will talk about is how we can add some context to the OpenAI platform. So something that these LLMs needs has some context. These LLMs, for example, the specific LLMs that I'm working with is trained based on millions of internet pages, and so it reads everything and get a good understanding of the language and some general knowledge. But if I'm going to ask some specific question, you need to add some context to it. For example, if you ask it, "Who am I?" that model will not know who am I unless I provide some context to model that the one that is speaking to you is Mehran. And after that, I can ask the model, "Who am I?" and it will answer me, "You are Mehran," based on the context that I've given to the AI. So also it utilizes its built-in knowledge. It also needs some context that most of the time we will give that context to the OpenAI and to the LLM and to the language model using a context that we can provide for those. Here in Azure AI, you can see that we can deploy a new model, and there are different models here. For example, you can see the ChatGPT Turbo, the different models, and each of these models have different specification and different context size. For example, this version of GPT-4 accepts 32 kilobytes for context, but this one accepts 16 kilobytes for context. Okay, and now let's go to the semantic kernel. Semantic kernel is my favorite framework for working with these stuff and these AI. It is a very well-structured framework, and it is open source. You can follow it and see it in Microsoft's repository. So if I search for semantic kernel, you can see this is the official page for semantic kernel. And also, if you want to see the GitHub, this is the GitHub. You can check everything about semantic kernel. So most of my presentation today would be about writing software using semantic kernel. And also what I'm going to add to semantic kernel is how you can build semantic kernel based applications and have test-tree TDD on top of it. So how you can write high quality application with a TDD approach. This is what we're going to talk about today. So two very important things about the AI. One was the, leveraging prompts. So if you want to create a good kernel to answer the questions in semantic kernel, one is utilizing a good portion of prompts in the context. So you need to prepare a good context and give that context to semantic kernel, or give some information to the semantic kernel in the various ways. And the other thing is to give the semantic kernel some functions, introduce some functions to semantic kernel, so the OpenAI can call those functions on behalf of you. So this is something very useful in designing kernels in semantic kernels. So in this meeting, I'm going to create a kernel from scratch, and essentially I'm going to write a REPL application, a very simple chat application here from scratch, and it's just like the way that Stefan Toop did in his presentation on .NET Conf, and in a few other presentations that he had. So actually, I'm starting my presentation by building something like Stefan Toop's, and then I will add semantic testing and skUnit on top of that REPL application. Great. So let's start some coding here to add some semantic kernel, and then skUnit, and then TDD. This is what you will see in next couple of minutes. Enough presentation. Let's go to the code and let's start some coding here. Okay, so let's start with here. CD source. I want to hear. This is the folder that I have my temp projects. Let's create a new folder for our demos. Let's name it sk demo, and then cd sk demo. Great. And now let's create our first .NET application for our. So I will use .NET new console application I want to create, and my console application is here, if you call it. Yes, so this is my program CS is made here, and if you want to check it, I can .NET run, and this is simply a hello world application, as you can see. So a simple hello world application, and let's see the code. One line code you can see here. So this is the program CS. It has a just simple hello world application here. And what do we do next? First of all, hello world. I want to say hello LLM world. Just chat with me. Okay. So let's build our first application to test my application is working. I'm going to do .NET run again, and so this would change would appear here. Great, everything is okay now. Now I want to add Microsoft, add the package here. So I will say .NET add package Microsoft.semantic kernel. Let's install the new package. Okay, so the semantic kernel package is now installed, and I can use it. To use it, I need a builder. So I'm going to create a builder here. Builder equal kernel.createBuilder. Okay, this is the kernel builder for semantic kernel. And after that, I want to create my builder. So I will have where my kernel is here, builder build. Okay, so this is how my builder would be created, but a kernel needs to be instantiated. So for builder, I will add builder, I will add my model. I will say that I need a add Azure OpenAI chat completion here, and it needs a couple of parameters here. So, for example, it needs deployment name and the Azure the OpenAI API key. I've already I'd already put them in my variables here. So I have these items here available: deployment name, endpoint name, and API keys. You can you will have your own here to provide, and after that I can use them here, as you can see. Okay, so very simple. I've just get my keys, and I kernel build kernel builder, and after that I've created my kernel. Okay, and let's save it here. And so let's start write a very simple REPL. You know, by REPL I mean read, evaluate, print loop. So it will be a very basic one. So first of all, I'm going to write string input equal this, and after that do while true. I'm going to have an endless loop, and after that I'm going to ask the user to enter something. So I will say the console that write, and then I will say just enter something. I will ask the user to put something here. User will type something here, and after that I will get my chat service. So I will have chat service, my chat service, and I will get it from kernel services, and the I need iChat completion service, iChat completion service, and my chat completion service would be ready here. Get required service. Okay, so I think I need, great. Now that I have my chat service, I can get the results. So my result would be chat await, chat service, chat service dot get chat message content async, and I will give my input here. This is my input, and I will pass the kernel here too. Okay, and after I've been getting the result, I want to show the result and say that the assistant or AI answered this. So after that, I'm going to say where console write line, for example, the assistant tells just answered me with this. Okay, so this is a very simple application with a few lines of code. I'm going to run it to see how it works. So first of all, and now .NET run again. Okay, so hello. I'm going to tell it hello. So what's the problem here? Okay, the problem is that I'm not getting the user input from the. I should have input. So we will have input equal read line. I've just forgotten it, and that's it. Okay. So again, let's run it to see how it works. Oh my God, I just lost it. CD temp and CD the skdemo here and .NET run here. Okay, hello, and it will answer me. It's something not right. Why is that like that? Let me check it out. Okay, so I'm get chat message content here, and I need contents. Yes, that was another implementation that I didn't need. So let me have a new terminal here. .NET .NET Run. Okay, saying hello. So hello, how can I assist you? I would, we can ask a question from it to see how much his information is. So, do you know my name? No, it doesn't know. So, I'm Mehran. I'm going to say I'm Mehran. When I'm saying I'm Mehran, it will answer me that hello Mehran, how can I assist you? And again, if you say do you know my name, it will know nothing again. Why? Because I'm not giving the AI the context that it needs. So I'm just giving it an input. So if I want the AI model to return me a good answer with some history, every time I'm calling this method, I should give it the proper context. So essentially, in this situation, the proper context would be the history of my chat. So it could remember that I once I said that I am Mehran, so it could refer to it. So for this, I'm going to add some history for here. So, for example, I'm going to add a history is a chat history here, okay? And the answer is whenever the answer is ready, I will whenever the answer, so this is the input, this is the result, and after that I'm going to whenever the user had an input, I will add that to the input. So I will say that history dot add user message, and so this is the user message input after the user had this input. And whenever the result is ready, I will add to the results. So after here, writing here, I will say history dot add message, and this time I'm going to tell it that here the result has some role with it. So keep it, and the result has some content also. Result content. Content that I know. Okay, so in this way, I'm populating a history here, and whenever I'm passing everything to, instead of passing just the input, now I will pass the whole history to the AI. Now let's see how does it work. C and again .NET Run, and now I'm going to say again hello. And it will answer me properly, nicely. And I say, do you know my name? Do you know my name? And he will not, because it doesn't know yet, but I'm saying that I'm Mehran. Okay. Oh my God. I'm Mehran. Okay, whatever. So now if I say, do you know my name? Do you know my name? Now he will know. So yes, you mentioned your name as Mehra. How can I assist you, Mehra? So you can see that now we've added something to our model, and it can remember the previous chats, and it can understand it, and it can remember it, and it can answer based on the previous chat that we have. Okay, someone is saying, okay, I will. Let me see if I can make it bigger a little bit. Okay, I'm making it bigger. Thank you for mentioning. Okay, so this is a program that is using a model, a GPT model here, and we're using semantic kernel for it. And for semantic kernel, we have written a very simple, very simple one, a simple scenario that it remembers the chat history, and it will answer us based on the chat that we've given it. So now here we had a chat history, and you know, when the first time that I was telling what's my name, it didn't know unless I told the model that I am Mehran. But now I can have some system prompt to the AI. So here I can introduce myself, so it will know that who is it talking to. So I will say the name of the client that you're talking to with is Mehran. Okay. Now within the application, I've told that the application, the one that you're talking to, is named Mehran. So now, if I instantly, without saying my name, say what is my name? What is my name? It will know your name is Mehran. Why? Because I provided some context for this model using this. And you know, you can instead of having this, you can provide this information from loading the database, loading from the base based on the request or the authentication process, authentication information you have from the user. You can pass it to the chat history, and from that time, the AI will have some information about you. Great. So that's it. And this is how it works now. Also, we can, because we are using semantic kernel, there are some better ways of adding and training our model based instead of just giving it a text. So for example, I can have a plugins folder here. Let's have plugins folder. Okay. And in the plugins folder, I want to add a new plugin called, for example, Mehran plugin. In the Mehran plugin, I'm going to introduce myself to the model, and let's like this. If the user asks about Mehran, I'm going to add some information about Mehran. If the user asks about Mehran, he's a software architect. And another file, I'm going to put some configuration to talk about how this plugin is useful. For example, here, I'm telling the OpenAI that this plugin and this method returns some information about Mehran. So if you ask about Mehran, it will answer like this. So let me check it out. Let's check it out. So far, if I ask who is Mehran, it will answer just with some general information, or apologize if there was a misunderstanding. So it's saying that it has no information about Mehran. But since I've made this plugin, now I can introduce this plugin to our kernel, so our kernel can use this plugin's information. So for this, I can here, whenever I just added the services, I can say the builder, the plugin. For the plugins, I want to add from prompt directory and just say that there is a directory called plugins, and I'm asking the OpenAI to use this plugins folder for some information. So let's restart everything again. Run. And now, if I ask who is Mehran, it's not understanding yet. The Mehran plugin is here. Let me check where's the plugins. I've added it to here. Okay. There's some other configuration I should apply for this kind of things to work. We need to tell the OpenAI to add to enable something we call invoking kernel functions. So we should let OpenAI to call some of our functions. In this case, the plugins are our functions that should be able to be called from the OpenAI. So here I will be before passing here, I will be create some configuration here. As you can see, this is the config the execution settings. And now I need to pass this execution settings here. So I will say the execution settings. Okay, that's it. So let's tidy it a little up. So this is the kernel and this is the execution settings. So here I'm saying that I want my OpenAI to use these execution settings, and here I'm going to let the OpenAI to use tool call behavior, so it can auto invoke kernel functions here. In this situation, the kernel function resides somewhere in escape from, and later I will describe it more. So now if I save this and again here .NET run here, and I tell user who is run. Yes, now it has some general understanding about me. It says Mehran is a software architect. How did it know? Because I've included this plugin here, and this plugin had some information. And how this plugin is going to work is here. And for this specific plugin, as you can see, you can set some advanced features like temperature. You can, for example, specify a higher temperature, so that the OpenAI will just use this information. But not it will use it, but not exactly the same information here. You will let the OpenAI to be more have more hallucination here. Okay, let's get back to some questions here to see. I think I have some problem with my camera here. Let me check it out. Try again. Okay, so let's get back to some questions and see what are the questions. So the first question is, can you confirm? Yes, I've been researching for about a month on building a personal language model that can communicate with one. I remember our conversation, and trying to look at this presentation came at the perfect time for me. Thank you. You're welcome. I'm really happy about it. And I've got a question. Let me show this question on the screen. So I've got a question. Can we build a memory function like ChatGPT's? You know, something that remembers context and keeps it even when they close and reopen the app. Of course, in fact, Semantic Kernel has very advanced tools for this. So in a couple of minutes, I will talk about them. But for being short, you can embed and integrate lots of things with semantic kernels kernel. For example, you can have different connectors. You can connect it to different vector databases, SQL Server, and with that, the process of memorizing everything would happen automatically. And the personal. My camera, I hope my camera is back now. Yes, I hope my camera is back now. Okay, great. So now let's do something a little bit different and change my prompt here. I want to to tell to change the prompt so it answers differently in different situations. For example, let's make it in a way that if it feels that I'm asking the question, I am angry, it answers me differently. For example, if I am normal, it answers me, yes, Mehran is a software architect. But but if it feels that I am very angry, it answer me that Mehran is a therapist. So let's change this here. For example, I can say if the user asking this question is angry, okay, then answer that Mehran is a therapist. Cool. Else, tell him Mehran is the software architect. Okay. So here, this is the new prompt, and let's check it out. It would be quite funny here. Okay, .NET run. Now I'm going to ask who is Mehran, and it will tell me Mehran is a software architect. Okay, and now I want to ask him who the hell is Mehran. So I'm so angry, and Mehran is a therapist. Now it is saying its internal thoughts. It's confused a little bit. You see, it's describing the logic that it is using because in our conversation it also mentioned that Mehran is a software architect. But if I run it again, .NET run, okay, and it's starting the conversation saying that who is Mehran? Who the hell is Mehran? Okay, if you understand that I am angry, and it should answer me, no, it's not working. If you're needing a therapist, I'd happy to. Okay, so if I test it with some, let me use some other provided here, maybe another prompt, and let again .NET run again. I will see who the hell okay, it's not working now. Maybe we need to have better prompts here. But I would give it some other try, maybe. So let's here and .NET run again, and who the hell is Mehran? Who the hell is Mehran? So I'm so angry. Who the hell is Mehran? So it's now saying if you're so angry, if you are angry, Mehran is a therapist. If you're not angry, Mehran is a software architect. So you see, it's now the fields that I am angry. It provides, it tries to choose some other options here. So it's quite funny working with this, because different times that you're working with this, you will get some different answers. For example, the last night that I was making this sample here, most of the time I was getting the answer that Mehran is a therapist when I was angry, and most of the time when I was happy, it was saying that Mehran is software architect. But the exact thing that happened in this presentation is the topic of this presentation. You see, the way that you're writing your prompts, the way that you're picking the models affects the way that the product works. Okay, but you want, for example, consider that our requirement was to make sure that whenever Mehran is angry, the 100% the system should say that Mehran is a therapist, and not describing, for example, its logic. It should answer that Mehran is a therapist in those situations. And this is when you need to write tests for your kernels. You need to write some tests to make sure that if the user is angry, then the answer should be therapist, and it should be testable and should be tested whenever you change the prompt. And this is exactly the topic that I'm going to provide with you uh, uh, in the next couple of minutes. So let's go to check another project that is written um, test in a test-driven way. So, for example, I can start another project. This time, I'm going to use Visual Studio to see how we can create these projects. So, I want to create a new project here in Visual Studio. This time, I'm going to write it in a TDD way. So far, the way that I was writing this REPL program was exactly the way that Stefan Toof was doing at .NET Conf, if you've watched that. So, but this time I'm going to do same thing and implement same thing, but more advanced one in using test-driven approaches. So first of all, again, I'm going to start the console application, and in my console application, I want to call it, for example, skUnit demo. Okay, and this is my this is my project name. This is the .NET 8, and I will create my project here. And I get in my project again. I will have a program CS here, and I can write all of the logic here. But this time I'm going to add another project here for to test this console application. So here I'm going to add another project. So let's add, yeah, let's add a new project, and this time I'm going to add a XUnit test project. So this is the XUnit test project. I'm going to name it as skUnit demo.test dash test, maybe. Okay, and in this project I'm going to add this time for this I'm going to add a new package that I'm going to use for tests called skUnit. Okay, by starting skUnit, here you will see that in the package you will see that skUnit and XUnit will be installed together, and now you can write unit tests for your system here. But I just wanted to show you how we can do it from the scratch, but I'm not going to do the whole thing here. I'm going to show you the program that I've written before. But before that, let's explore a little bit on skUnit and what it is, and how it can help us doing how it can help us here. So first of all, let's open up browser here. I'm going to show skUnit test library and see. So this is the GitHub for skUnit, and here we can see how skUnit works. So as you see in the presentation, we were trying to write a good prompt with a good model to satisfy the business need. The business need was I wanted to make sure that whenever Mehran is angry, answer him that Mehran is, whenever the user is angry, answer the user that Mehran is the therapist. Whenever the user is a normal way, is a normal situation, answer the user with the software architect. So this is the tests that should be passed. Okay, so here in skUnit, you can define your scenarios. Okay, for example, let me go to the here. So this is a chat scenario. So this is a scenario that I'm just specifying and determining what is my expectation from the model, whatever it is, whatever the technology is, whatever the parameters, its parameters are. But I want this scenario to be passed. What is the scenario? I want this scenario to be passed. If the user asks, uh, is Eiffel tall? Is Eiffel tall? The agent should answer, yes, it is. The AI should answer, yes, it is. But as all we know, there are multiple possible of ways that the AI can answer us. Okay, it may say yes, it is. It is. It may answer sure, yes, it is. Why not? So we cannot check the answer through, for example, the yeah, string comparing strings or contains or whatever like that. We need some way of checking the answer semantically. For example, in this case, we are telling that the AI should answer yes, it is, or if it or whatever it answers, it should have a semantic condition. The answer should have this semantic condition. The answer, the condition is it agrees that the Eiffel Tower is tall or expresses a positive sentiment. So this is that we expect from the AI's answer. If it is not, yes, it is. Okay. Then again, if the answer, if the user says, "What about Everest Mountain?" The answer to what about Everest Mountain should be yes, it is tall too. You know what about Everest Mountain? When we're asking what about Everest Mountain, we expect the AI to have the history and know that the previous question was about something being tall. So, what about the Everest Mountain? The answer should be something like this: yes, it is tall too. So the answer should be a positive. And again, the answer should has this semantic condition. It agrees that Everest Mountain is tall or expresses a positive sentiment. As you can see, this scenario is a compound scenario. Although it looks like a chat, okay, it looks like a valid chat, but in fact, it has two scenarios within it. One scenario is this, and one bigger scenario is this. So you can see here, such scenario is a compound scenario, and the first scenario, the sub scenario one, is the answer to is Eiffel tall should have this semantic condition, approves the Eiffel Tower is tall or is a positive about it. The other scenario is this: if the user says is Eiffel tall and the AI had answered it to yes, it is. And again, user asked, what about Everest Mountain? In that situation, either the answer should be this or the whatever the answer is, it should has this semantic condition. The sentence should be positive. So as you can see, we're creating a compound or a mixed scenario here, and the magic that skUnit is doing is running this automatically. So you know the way that we are describing these scenarios is like markdowns. It's a valid markdown here. The skUnit will read and understand this and compile this markdown and converts it to a valid scenario, and it will run it. It will run this scenario here, and a output of the scenario will be something like this. So, for example, if we run this test, the result would be like this. I will see this. I will show you this one here to you in a live application too. So let me open it here and wait it to be open. And okay, so the result would be like this. If I run this test, it will start. It will show that user says if is Eiffel tall. Expected answer was yes, it is. But the actual answer was yes, the Eiffel Tower is tall. It stands at this much and some more information. And the check condition was approves that Eiffel Tower is tall or is positive about it, and it is okay. So this test is passed. The other test is that now user says, what about Everest Mountain? And what about Everest Mountain? It will say that yes, the expected answer is yes, it is tall too, but the actual answer that AI was responded was yes, Mount Everest is tallest mountain in the world, and the check condition was the check is positive and it is okay too. And in this one, we had another question here. What about a mouse? What about a mouse? So expected answer, it is not tall. So let's check the other, the check the scenarios in the live environment. So um, this is a test written using scenario test. We have some samples here and Eiffel chat. So this is the samples, the plugins, and I want to have look some scenario, find some scenarios. See here, this is the Eiffel chat, this is the chat. So this is the markdown. Okay. So as you can see, this is a test here, and the tests are valid markdowns. So they are really good the content for really good content for business teams, so they can write tests and they can write tests and understand it, and it is so readable for other business team for your company. So if I found that test, let me find it. Work, the function call, and this. So these are the different tests that we have. So let's see this test here. So I want to right click on it and run test unit. As you can see, when I'm running this test, it will show like this. What happened here? So no, this is the scenario was just for parsing. So semantic kernel test in here. Eiffel chat, maybe yes, the Eiffel chat. Okay, it's saying that it's passing, it is okay. So this assertion condition is passed yet. So you can see that all of the features has passed. Again, if I run it again, you can see that is the test is doing and passing incrementally, and you can see the way that it's doing the chat and it's doing the chat and checking the answers. So it's a very safe way to write reliable software using this. And there's a documentation about all of the different check statements that we can have for this system. For example, if you expect some JSON things, there are lots of features for JSON for checking the JSON semantically. Great. So before getting back to Visual Studio, let's check for some questions that you had so far. Okay, the next question is Mehra. My question is about the pinned icon at the bottom of the screen. Oh, okay. Yes, I've just forgot about it. The escape from text. You are helping me. Thank you. Okay, and you know what's cool? GitHub Copilot uses semantic kernel to grab code context from IDE sent to GPT model. Yes, it's very cool about this this feature of here. Sorry about forgetting that sticky pin appearing on screen. Okay, so here you can see different, there's documentation here. For example, there are different check statements that you can use when you're checking. For example, semantic condition checks that if the answer has this condition. Semantic similar will check that the answer should semantically similar to this answer. We have lots of other stuff here, contains any semantic similar, semantic condition, JSON check. For JSON, for example, I'm JSON check. It says that I expect the result to be a JSON, and the JSON should have a name and a description, and the name should be equal to Mehran, but the description should semantically has this condition. It mentions that Mehran is a good software architect. So you can check and assert different fields of your JSONs here using the JSON check and the other stuff. Okay, so get back to the Visual Studio and to another REPL here that we have. Okay, so this is a very simple program again, and in this program we have just that the loop that we have. So here the loop starts. We're asking for user input, and we're passing and getting the result for that input, and we're showing the answer. The one thing is different in here is that instead of directly using semantic kernel, I've put all of those code into another class. I'm calling it brain. Okay, just a refactoring to make my code more testable. So what is in brain is very simple. It has a constructor. In the constructor, I'm just building my kernel, preparing my kernel, the exact same code that we had before, and I have encapsulated the get. I have added get chat answer async that is doing the same. I'm getting the chat service. I'm calling the chat service get chat message content against passing all those parameters to it. So nothing. So essentially nothing new is in brain. Just I've refactored my code. So my code here, my console application is using brain. So why did I do it? I'm doing it because I'm going to test my brain in another project. So as you can see, I have another project, demo TDD REPL dot test. And in tdd.repl.test, it's a simple xUnit test. The only thing it needs for to be prepared for skUnit is these bootstrap code. Here I'm passing endpoint API and deployment to my scenario assert. This scenario assert is skUnit essentially. It is a part of skUnit. And so I have the scenario assert now. I can use it in my writing my tests. So the first test is greeting. Okay. So for greeting, I'm going to pass something to be tested. Okay. So in the documentation of the semantic kernel, if you go here, it's saying that if you want to use it, you need to load your markdown to a string, and this is chat scenario load from text. This is skUnit will parse your markdown to a valid scenario, and then you can pass your scenario to scenario assert, and the test will be tested. Okay, so in our code here, as you can see, I'm loading the chat scenario from a resource. Where is the resource? The demo. This is the address of the resource. The o1 dash greeting.md. So this is the scenario. This is the address. So you know, so that you can see, as you can see, the scenario is a markdown file. It can be seen by a business team. So you know, in this scenario, it is testing this. The user, if the user says hi, the agent should say hi. How are you? Okay, and there's a check semantic condition. It's a greeting or expresses a positive sentiment. Great. So now, if I want to run this test as it is a valid xUnit test, we can see here. Let's check it up. Here it is. This is a test. So if I right click on it and run the unit test, I will see that the scenario, the user says hi, the expected answer is how are you, but the actual answer is hello, how can I assist you today? And the check condition, that is, it's a greeting or expresses a positive sentiment, it is okay. It passes now. Great. So this is the first test that we had so far. The second test is a little bit more tricky. The second test is saying that if the user says hi and you will say hi, how are you, and the check semantic condition, it is just the same. But if the user says who is Mehran, and the answer should be Mehran is a software architect. Okay, and the condition it should mention that Mehran is a software architect here. Okay, and if I come here and run this, it will be passed, as you can see. Okay, it's passed, and it say the actual answer, Mehran is a software architect. If you'd like to know more about Mehran or any other question, and the check condition is it should mention that Mehran is a software architect. But why how does it know that Mehran is a software architect? It is because I've added a people plugin here. But this time I've added another plugin. So here with people plugin here, and this is there were a plugin here, just like the way we had the old one, but a new kind of plugin. The semantic kernel supports is native plugins, which I'm very exciting about it. In this way, I'm writing another plugin, the people plugin, that will for example, get person info. It is a C# code, you see. Okay, people plugin is a C# code. It has a method in it, and this method we have get person info, and get person info has an input. You get the person name and the user attitude. I'm saying that get person info gets a person name and user attitude, and the user attitude I'm describing that it would be something between angry and normal. So, and in the code, I'm writing that if the user attitude is angry, the return person is a therapist. And if the person attitude is software architect, return that the user is software architect. So I'm adding this plugin to the brain. So instead of a textual prompt, I'm integrating it with a C# method that is integrated into our builder. Okay, so let's this time I'm going to run the test again here, but this time in debug mode to see what will happen. This is quite interesting. When it's running, all of a sudden the AI calls my C# method with a proper value, and it says that the value is normal. So I just asked the AI to provide me with user attitude, and just with description, the AI understand that it should that should check the content of the chat so far and see if the user is normal or is angry, and pass that user attitude to this. And again, AI knows that this method needs a parameter for person, and it tries to extract the name of the user, and now it knows that it is Mehran, and it's passing Mehran and user attitude, the normal, to this C# application. And my C# application with a if I'm saying that if the user is angry, answer this, or otherwise tell that Mehran is software architect. This is because this is how it's answering me with C# with architect. But let's take the other scenario here. We have other scenario here. In the other scenario, I'm saying who is that fucking Mehran? It is really angry. And then for this situation, if I put again run this, if I want to run this one here, debug, you will see that passing this test we will have here. Oh no, we want to debug unit test. Oh, I think people plugin. I just removed. Okay, here you can see that this time this function is called with angry. And who is sending that? It is OpenAI. The OpenAI using the function hall extracted the angry from the as the sentiment of the chat so far, and is calling my C# code. And this is why now my test is being passed. It's cool, very cool. And how am I introducing this feature to OpenAI? But this kernel function, I'm telling that this is a kernel function that should be useful for semantic kernel. This is a description for it, and this is description for each of these parameters, and all of those information will be populated and being integrated as a system prompt whenever the semantic kernel is passing a request to OpenAI. So all of this is being handled with semantic kernel. And our code, what is our test? Let's check our test. This is our test. For example, if I'm testing my brain, and I'm loading my scenario from this resource, this file here, and I'm just passing my scenarios to scenario assert and letting the scenario assert to populate based on I'm giving it a function that if you want to get a result from the history, this is how you should do it. They're using a brain I have. So I'm passing this lambda here, and this lambda, the history, I'm giving the history, and I'm getting back the result. And this is the way I'm introducing how this, what function am I testing. This is what I'm testing using these scenarios. Okay. And so let's get back to questions, if there are some questions. Okay, so Hutan has a question. I have an additional query. Is it possible to utilize the skUnit library to interface with our local LLM, such as Llama model or Phi model? Oh, yes, absolutely. Exactly at this place. So if you want to test something else, you can in the brain, for example. In the brain, you can configure semantic kernel to connect to lots of other models like Llama, like the other stuff, GPT models that we have. And once you've set that, nothing is changed. You just configure to check another model here. And also, as you can see, skUnit doesn't force to use semantic kernel to test. But here, you can use anything other than semantic kernel. For example, here, I'm not using semantic kernel. I'm just using brain class a method in it, get chat answer async. Well, whatever you want, you can put in this method. So skUnit does not force you to test semantic kernel based things, but internally skUnit is using semantic kernel to do all this semantic stuff. Thank you for your great question, Hutan. And is it possible to integrate the skUnit library with NUnit or MS test? Currently, it is currently the let me put it this way: the scenario assert has nothing to do with xUnit. So once you configure it here like this is the way that we can configure it in xUnit. It can be used in NUnit or MSS or whatever, any other test platform. But I had some documentations and some stuff specifically for xUnit that makes this the skUnit more suitable for xUnit. In the future, we will add some NUnit and MS test support too. Great. So, any other question here? No question here. Great. So far, as you can see, we've wrote some scenarios here, and I want to introduce you the last scenario. The last scenario is a bit tricky. In this scenario, I'm saying that I'm changing my mood. The first time I'm saying, who is that fucking Mehran, and it will say Mehran is a therapist, and then I will change my mood and say, oh, that's cool, I'm very happy. Again, who is Mehran? And I expect when I'm changing my mood, the Mehran is a software architect should be the answer. This test weren't passing when I was using this skate prompt, because the if part was somewhere within the language, and for some reason, most of the times the OpenAI couldn't understand they couldn't decide whether to answer Mehran is a therapist or a software architect. And so for in some cases, as you would you had seen already, it was answering me that Mehran is both therapist and software architect. And if you are angry, I will say that kind of answers. But with this new way of writing prompts that somehow is integrated with C sharp, this task is being passed. So this is it's a much more complicated scenario. And if I run it, you can see that it's the scenario who is Mehran, expected answer was that, the actual answer was this, and it is passed. And again, who is the fucking Mehran? The expected answer is therapist, and the actual answer was Mehran is a therapist. And again, I'm saying, oh, that's cool. Now I'm very happy again. Who is Mehran? Expected answer is to be software architect, and the actual answer is again software architect. So it passes it should mention that Mehran is a software architect here. So this one is very cool situation that you can see how we can have fixed scenarios, fixed expectations, semantically describe your expectations, and now you can change your prompts, change different technologies. Maybe you want to, at some point you want to change your model. For example, here I'm using GPT 3.5, but at one point you may decide to migrate to GPT-4, GPT-4o, or other versions, or for example Llama or Phi. And but although you are changing the models, changing the prompts, changing, for example, the prompts to from the raw text to a native plugin like the C# ones, the tests would be the same. And you can make sure that whatever you've written so far and whatever you expect from your kernel will still be valid, because you write lots of tests for this. So for example, for this application here, you can see that there's lots of tests here to pass the test. And you can for example, here you can see that there's lots of tests that's being happened to check the validity of the application, and all of these tests are semantic tests. So in this way you can make sure that your AI-based product works well in different scenarios with different situations. That's it. And now let's see if there are some questions here that I can answer. Let me stop sharing my screen. See if there are some questions that I can answer here. I hope so. The answered questions. Any other questions? Hello. Let me go to the LinkedIn and see if there are answers. Okay. In all examples we've covered today, we focused on text. However, with LLM support. Okay, yes, very good question, Hutan. So let me read it aloud. In all the examples we've covered today, we focused on text. However, if the target LLM model supports it, we could explore using images, voice as well for testing purposes. Is it right? And can we test? Very good question. Yes, Semantic Kernel and OpenAI now support working with images and voice. And currently, Semantic Kernel scenario building in the Semantic Kernel does not support images and voice, but we have it on the roadmap. So on the roadmap, we will add support for example, in the scenario markdown. In the scenario markdown, you will be able to add some images and have some prompts and then ask some questions regarding that image, and for example, have semantic semantic conditions over that image, but now it is not supported. Thank you for the question. Any other question? Nope. No question anymore. Okay, great. Thank you, everybody. So yes, we've done everything here. We've developed a REPL, just like the Stefan Tubes one. We've refined our REPL application for testability, and then we implement semantic tests, and we've investigated some semantic kernel functions and how they work. Great, thank you, everybody. I'm really pleased to be. I'm with you today within this meeting. Really excited about it, and please let me know of any question you had or any feedback about it. I am @Mehran DVD everywhere, mostly on Twitter. You can find me, and thank you. That's great. Have a good day.